So if we're going to be doing the volume of cylinders, we need to define cylinder. Now a cylinder, of course, is a three-dimensional object with two parallel congruent circular bases. Now for it to be a right cylinder, those two circular bases need to be directly above and below one another. Basically, they're at a right angle to the lateral surface or the side. So let's sketch a right cylinder. It's good to get good at these. So I just start with a circle, two straight down, and then a curved bottom. You can also do one lying down, doing the same way, just an oval, two parallel lines straight back, and a curved bottom. Now if we want to draw the inside, of course we can dash it like that, or like that. It doesn't have to be perfect. You can see this one's not real perfect. The radius, we need to know about the radius of a cylinder. So the radius is going to be, it's easiest of course to draw it right here or possibly down here, but realize that radius extends all the way through. So from here to the side, and from here, and of course it could be to the other side. I mean, it could be anywhere, right? So I could draw the radius in this one from here to there. Now that's not usually where you're gonna see it. I just wanted you to know that, keep that in mind, that it can be there. We usually show it on one of the bases, either the one you can see better, and sometimes you'll see it on the one in the back, and it may not be dashed, it may be solid, but it's still gonna be the distance from the center of the cylinder to the side. Now let's talk about the height. The height is going to be the perpendicular distance between bases. So in this one on the left, we usually show it like this. But a lot of times we'll even show it on the inside. And remember, we're looking for the perpendicular. But it needs to be the perpendicular distance between bases, because there's also such a thing as an oblique cylinders. Now oblique cylinders, the bases are not directly above and below each other, but they are still in parallel planes. So a good way to draw an oblique cylinder would be to do something like, try again to make those sides parallel. So that would be oblique. Now the height is still the perpendicular distance between bases. So we would not, this would not be the height. That would be the middle, but the height, I mean, even if you did something like this, but it's still got to be the perpendicular distance between bases. So this is the height here. You can show the height here. This would be the height on this one. You can show the height in there. It's the perpendicular distance between bases. Let's look now for a minute at the net of a right cylinder. A net is when we open it up. So if you can imagine taking this cylinder, popping the top up, popping the bottom down, splitting it right down the middle, and opening it up, that's what we want to do to create the net. So popping the top up would be a circle, popping the bottom down would be a circle, and then splitting it down the front and opening it up, it's just a rectangle. The reason why I show you this is because I want you to know how to get the volume of a cylinder if we forget it, right? So volume, now remember our generic volume formula is capital BH. Capital B is the area of the base shape, whatever shape that is. In this case, it is a circle. So the area of a circle is pi times the radius squared. And then the height is going to be the distance between bases. And again, maybe in parentheses, I put the perpendicular distance between bases. I mean, that's a given, but it's good to remember. And so in this case, the height is still the height, or the h. And so volume of a cylinder is pi r squared h. Now the net actually is going to come back into play when we do surface area. So not right now, but I want you to keep this net in your mind. So now let's simply find a couple of volumes. If you'd like to try these on your own, pause the video, Try it and then check your work with me. I'm always going to start by writing my formula and then plugging what I know. We're always going to use 3.14 for our estimation of pi. The radius is 3.5 because they gave us the diameter here. And now I need to use my calculator. And so I get 192.325. And since this is volume, I need it to be cubic centimeters. You can also write that as cm with a little 3. The blue one. Again, I'm going to write my formula. Pi r squared h. 3.14 times 6 squared times 15. I got 1,695.6 cubic inches. And again, I can either write in cubed or CUIN. Now, what's kind of fun is to see if I can kind of work backwards. What if I want a cylinder with the same volume? Well, let's just go with the one I just did. But I only want it to be 10 inches tall. What does the radius need to be? So now what I've got is, I'm still going to use the same formula. Let's change back to the pen. Pi r squared h. But now I know the volume. 1695.6 equals 3.14 times 10. That's the height. But I don't know the radius. So really I'm going to divide both sides by 31.4. Can you see what I just did? I just multiplied 3.14 times 10. And I've got 54 equals r squared. Now I can estimate my radius right now because I know 54 is a little more than 49, so I'm going to estimate around 7.2. But let's go ahead and square root that to get a decimal approximation. And I got 7.348 ... Well, I guess since we're rounding it, we should put approximately. So it's really approximately 7.3 or 7.35 inches, since this is the radius. And again, not equals. It's close to the radius. So now what if I wanted the radius to be 10 inches? What would the height need to be? So again, I start with my formula. Pi r squared h. My volume is 1695.6. My approximation for pi, 3.14. My radius, we said, is going to be 10. And now I'm solving for height. So now I know I'm going to divide both sides by 314. Hopefully you see what I did there again, which is 10 squared is 100, and 100 times 3.14 is 314. Not surprisingly, we get 5.4 inches equals the height. But notice that we can work backward, having the volume, finding either radius or height. We do have to know one of those in order to find the other.